parts. So integration by parts. It pretty much does everything else. So, you know, we've done completing the square. We've done, again, let's review that. You know, this would look like a completing the square question. We've done a U substitution. We've looked at trig substitution. We've done partial fractions. We know how they look like now. The only thing that would be left is something like this, you know, ln x on x squared, let's say. Well, that doesn't look like it's a U substitution. It doesn't look like it's a completing the square. Definitely doesn't look like partial fractions. So you're kind of stuck with this. You know, you're not sure what to do with it. And that's when integration by parts comes in. It's the last bit of new integration that exists in the whole world. In fact, there's nothing greater than integration by parts. So even at university level, the hardest questions can only be done by integration by parts. Cool. For those who get into engineering, finance, economics, commerce, anything like that, statistics, math, obviously, teaching, you will need integration by parts pretty much in your first semester. So, all right. What do we need to talk about? There is a formula for it. So the formula is uv minus the integral of v du. So uv minus the integral of v du, and this is the integral of v, of u dv. Oh, all right. That looks very complicated and it sounds very confusing, but I promise I'll always make everything easy, so don't stress. But that's the formula. So technically, you're integrating u with dv, and you're allowed to break that up into u times v, which is already integrated, so you don't need to worry about that, minus the integral of v du. Okay. So what this is trying to say is, technically, this particular function, I might get rid of this, actually, and do an easier one, just to begin with. There's a particular function, and let's just say this one here, x ex dx, and you would have one component that is, how am I going to say this to you guys? One component that is from a different family to the other. So one component that is from a different family, to the other. What I mean by different family is this particular acronym, and I want you to memorize this acronym. This acronym tells us what to differentiate first, if possible. Now, does anyone want to take a guess at what they think these letters stand for? When I'm talking, yeah, L stands for?
Logs.
Logs. I?
Indices.
Ooh, no.
Inverse.
Inverse what?
Log.
Inverse, not inverse log. Inverse trig, yes. Inverse trig. And then what does A stand for? Just basic, everything else pretty much, which would be algebra. So any basic algebraic expression. T, what would T stand for?
Trig.
Trig. And last one.
Exponentials.
Haven't written like this since I had to write, exponentials. Since I had to, back in primary school, we used to do those poems, right? You used to put your name, and then you used to write super amazing man. So I haven't written like this forever. Oh gosh. All right. So you guys get the idea anyway. So what integration by parts is doing is it's allowing you to allowing you to integrate the product of two different families together, and it splits it up into something else, which is going to work for us. Now, this particular acronym, LIATI, or however you want to say it, tells us what to differentiate first. And the reason why that's important is because if I had a log with an exponential, so let's say if I had 2 to the power of x and then it was multiplied by ln x, let's say. And if you're trying to pick out what to integrate first, to differentiate, and you said, oh, I'm going to differentiate this guy and then I'll integrate this guy. Well, the integral of a log, just so you know, is integration by parts anyways. You can't integrate log, if you guys remember that. Integrals of logs are impossible. We can differentiate logs. You can differentiate a log, and then that becomes 1 on x, derivative of the inside over the inside. Or we can integrate 1 on x to get a log, but we've never integrated logs. That's impossible for now, until we learn obviously integration by parts, which makes it possible. Same thing with inverses. We've only ever, you haven't realized it yet, but we've only ever had something like this, and we said, oh yeah, that becomes an inverse sign. True? We've integrated this algebraic expression, we got an inverse sign. And vice versa, if you had to differentiate this, you would get to this. But we never integrated inverse trigs. We've never integrated inverse trigs. So these two are super hard to integrate. So you don't ever want to integrate them. You would want to differentiate these two, if possible, right? And then, let's rub all this out because you won't need it just yet. What you need is just this acronym more than anything. And then the idea is, if you have, and the reason why I've written it in this order is if you've got, let's say, log with a trig, the idea is you would differentiate the log and you're going to be integrating the trig. And the reason why you don't mind integrating trig is because you have freedom with trig, right? If I was to differentiate sine, that becomes cos. Or if you said, hey, integrate sine, hey, that's very possible. That just becomes negative cos. So it's not a problem. You got freedom with trig. So as you work down these letters, like exponentials, if you remember, exponentials are just exponentials. Yeah, even if you integrate an exponential, it's still an exponential. So you've got a lot of freedom down this way. So you don't mind differentiating this, integrating this, doesn't bother you. But up here, there's problems because you can't actually integrate logs and inverse trigs. All right. Anybody have any questions for me? No? Great. So let's see what the heck to do here. So the way I like to write my integration by parts is something like this. U equals dv equals. So U, then dv. All right. Then, so what you've got to write these two. Then you're going to write du right next to d. All right. After u, you're going to write du, and underneath du and on the side of dv, you're going to write v. So You're going to write u dv. Then this becomes du because you're going to differentiate this. This is going to become v, which means we're going to integrate this. So we're going to differentiate here, we're going to integrate here. Any questions about what I've written here? All right. These two must be these two. Oh, sorry, it must be this, all of it. All right. Now, before I just finish this off, just so we can get understanding something, back when we were doing use, like, you know, basic u substitution, if I said u equals 3x, can anyone remind me what I would write for du?
3x dx.
Ooh, close.
Wait.
3u du.
3, nope.
3dx.
3dx. You said 3x dx. You didn't need the x then. And don't use u because you're already writing du. So it's just meant to be 3 and then dx. So what I wanted to show you there is when we've written, I guess, u's or v's, we didn't have d's. They didn't exist. But whenever we wrote d's, we had d's on this side as well. So when we have d's here, we've got to have d's. When we've got u's and v's, they shouldn't have d's. All right, you've got to get used to that. So rub this out again. And we're getting very close. You're going to see how simple this is. All right, using this Lie-80, which one would you differentiate first? The algebraic expression or the exponential? Well, it says A before E, so you probably want to, you might as well differentiate the algebra, right? Because look, you're going to reduce it when you differentiate. So that goes X, and then dV must be whatever's left, EX dx. So these two, well, U and dV must have everything here. You cannot miss a thing. All right, any questions? U, you pick your X, dV, you pick the other one, EX. Okay. What is the, now, du? Du means differentiate this. So what's the derivative of X? Well, that's just 1. So you're going to write 1 dx, or in this case, I'll just write dx. I think we can start ignoring ones, yeah? dv, to go to v, means you have to integrate. So you know what I might do, just so you guys keep this in mind. That is what we need to have. All right, integrate. How do we integrate exponential? What's the integral of e of x?
E of x.
Still e of x. The only thing you have to remember is when we're integrating exponentials, you differentiate the top, which is 1, and then because you're integrating, you're meant to divide by 1. But that's silly writing that. So for now, over 1. That's perfect. Okay. Any questions for me at this stage? Anything that is confusing you? No. I make everything look easy until you guys start it. All right. Then the formula, look at it, what I've written, uv minus integral of v du. Personally, I don't even remember this. I memorize obviously just what I've written for you guys, u dv, and then I know if I've got dv, I'm meant to have v, and if I've got u, I'm meant to have du. This differentiate, this integrate, I know this acronym, and then I just think of it as a big tick because I'm going to get every question right. So it's these two, uv, see, u and v, and then these two, v du, v du. There it is. So backwards tick, or however you're going to look at that. So it's this and this. So ready? This can be written as xex, this times this, minus the integral of this with this. So EX, and that's why you need to have the D there. DX. Any questions? And obviously you got to finish it off, right?
Can you do that again?
Yes. So tell me, Stefan, what bit? Tell me what bit you didn't get from there, just so I know.
Just that line,
Yeah, but what bit? Like
the whole thing.
yeah, I get it. Okay, wait.
So what
Sorry?
So what has the times by what? So UV.
Yeah, that's the thing.
Oh,
Like
never
you can
mind.
memorize this, right? But I don't want you to memorize this. I prefer you to think of it like the way I see it, which is it's these two. Like I see, like I don't know, like I said, a backwards tick or whatever. It's this minus this. Again, this minus this. But if you want to look at the formula, it does say it's U times V. So U times V. X EX. Do you agree with that?
Yeah.
Minus V du. So V with du. So therefore it's going to be EX with DX.
Yeah.
Does that make sense? But just think of it as a tick. I like that tick more.
All right.
This two minus this two. 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 That's all I want you to memorize. This two minus this two. It's better than UV minus integral V du. Like no one's gonna be bothered. No student does that. So just this two minus this two. This two minus this two. That's why I write it like this form as well. All right. Last line. That is already integrated, so you don't do nothing to that. That's why there's no integral sign. You have to integrate this. What's the integral of E of X? And you're done. The integral of E of X is still EX. That's it. So you're almost, I don't know if you want to think of it as double integrating, but you're not. So there it is. That's it. That is the integral of X EX. X EX minus EX plus C. All right, let's try it again with another question. Just a basic one. By parts will probably take us, I would assume, 3 weeks minimum. So ln x dx. All right, who wants to try it? It's better to get things wrong, so just tell me. Who wants to go for it? I'll walk you through it. Don't worry. Just pick someone. Come on.
Yeah, okay.
All right, done. So, do you remember the first letter here that you're meant to write? U. Then underneath it, you would write
DV.
DV. Now, U and DV must be all of this. So just keep that in mind. All right?
Yeah.
Now, next to U, we have DU, and next to DV, we have V. Okay, the acronym was LIATI. That tells you what you should differentiate first. So now you've just got a log and then a dx. So
Yeah.
definitely the log ln x, you're not going to put it down here.
No.
That would be wrong. Because if you put it down here, I mean, look what you're going to write. You're going to write ln x dx. Well,
That's,
what's the integral of ln x dx? Well, that's the question anyways.
yeah.
That's silly. So differentiate the log first. So where does ln x go?
As
U. And then what would be dv? dv equals?
DX.
Yeah, right? Don't overthink it. I did say these two must be all of this. The
Yeah.
only thing left is dx. All right, good man. what is the derivative of a log x? That's the one you say the derivative of x over the x. So what's your answer for that one?
Right, x over x.
No, derivative of x over x. So what's the derivative of x?
Of just x?
Yeah, just x.
1
1. That's how we do it. Over,
x
and then you write.
plus c.
Oh, no. Don't do that.
Oh, dx.
dx. Yeah.
Yeah,
Plus these are all at the end when you integrate it and stuff.
yeah.
All right. Now we're going to integrate just the 1 dx. You're integrating technically 1 dx. What should that be? Don't overthink it. You're going to increase this up by 1 power. What's it going to technically be?
1 squared.
No, it'll be x. Right? It's a constant 1. You're going to go up and you're going to get x.
Put it up 1.
No, I know. No. You're integrating the 1 dx, it should become just x.
Yeah.
Again, the way I sometimes see it, if you ever get confused, think about it. I'm trying to get a 1. What thing would have got me a 1 when I differentiate it? Well, you know that's x.
Yeah.
All right. Any questions for me at this stage? Because you pretty much did the hardest bit. That is the hardest bit of integration by parts. So let's recap. We chose log because we said differentiate first. So there it is. We differentiated log x, which is 1 on x dx. You have to get more and more comfortable with that as the weeks are going by. The next dv is dx, and then we integrated that, which is x. All right. And then, so therefore this equals now big tick. So it's this minus this. So what are you going to write? These two together. What is it?
ln x.
X ln x.
Yeah, x.
Yeah, we don't say ln x times x is not ln x squared. Careful. It's 2 different things. X ln x.
Minus.
Integral. And then these two multiplied. What's x times 1 on x? Well, I'll write it now. Because your first time. But what happens to this times this? Cancels.
So 1.
Again, you just got the integral of 1 dx. Or just dx. What's the integral of 1 dx?
X.
X. Plus.
C.
Yeah, that's when we write plus c. Once you've integrated everything, you write plus c. Good. That was good. For first time. That was amazing. But now you guys know how to integrate logs. So to be able to integrate logs, you must use integration by parts. And that is the integral of a log. X ln x minus x. All right. Good work, Stefan. Anybody have any questions for us at this stage before I move on to another one? I'm not going to do that first one because it's got limits. So we're going to try, we'll try this one. Okay, use integration by parts to find the integral of x cubed ln x. Okay, who's going to give this one a shot? Let me just pick, it'll probably be quicker. Where are we? Skype. After Stefan. All right, Azra. Use integration by parts to find integral of x cubed ln x dx. What's your acronym?
LIAT.
Yep. So obviously, you've got algebra and you've got log. Which one are you going to differentiate and which one are you going to integrate?
Differentiate the log. And
And
integrate the
integrate.
x cubed.
Done. Let's go for it. So you've got u, then you've got du, you've got dv, and you've got v. What's going to be your u? So you said differentiate. So which one's going to be your u?
The log.
So you're going to write ln x, and then dv. Tell me everything you would write.
X cubed.
X cubed.
And then for the du, it'd be 1 on x dx.
Just this bit. It's not finished. X cubed.
Dx.
Beautiful. Remember, everything here has to be everything here. Good job. And then du becomes
1 on x dx.
done. And then integrate x cubed.
That would be x to the power of 4 on 4.
Now, it might sound a bit silly going, oh, but Sam, you had cubics and you just increased it in power. You might as well have differentiated the cubic so you can decrease it in power. Yes, true, if this wasn't a log. Because a log, I don't have much leeway. I can't put the log here. Because if I said, oh, integrate a log, well, to integrate a log, you got to do all of this. So you're not going to do that. You're going to follow this rule that I've written, and we end up with this thing here. All right. Equals. All right, Azra, tell me.
You would go ln x
Yes.
times x to the power of 4 on 4 minus the integral of ln x
Ooh, no,
on
these
x times 1 on x dx.
Say it again. X.
X to the power of 4 on 4
Yep.
times 1 on x dx.
Yep. Perfect. And then what happens is that, I mean, eventually, as you guys get better and better at this, again, I'll go up for a second. Look, if I mean, you have to get to this level. X times 1 on x, in your head, you're meant to go numerator, denominator, cancels out. So I don't want you to keep writing this and then canceling, wasting a line. Right? Same thing with this one here. X4, you know, is on top. X is on the bottom. You're meant to say x cubed's on the top. Right? But obviously, all of today, I'm not going to do that, but it's important that you guys start seeing this stuff. So this becomes x cubed on 4. You agree, Azra?
Yeah.
And then you got a choice. Do you want to integrate with the division of 4 here, or do you want me to take it on the outside?
Take it on the outside.
It's up to you. Are you comfortable with the 4 here? Like, do you know what to do with it if it's in here?
Yeah.
Okay, then you might as well just leave it in. Let's not waste the line. Log x times x4 over 4. Take away. Well, x cubed becomes x to the power of x cubed when you integrate it.
X cubed becomes x to the power of 4.
Over. No.
Wait, that's not your message.
What do you say?
Yeah, open 65.
What do you say?
Something about agreeing.
Azra, any ideas?
Agreeing.
No. Yeah.
Okay, close. Look, so x cubed, you set up here, x cubed is x4 over 4. So isn't x cubed at least x4 over 4? But then don't you have a 4 as well still here?
Yep, so you tie, yeah.
Yeah. Does everybody get that? If you guys don't feel comfortable doing that, then you could have just done this. Minus a quarter x cubed. Then you could have integrated the x cubed, which is there, and then that still becomes. So it's the same thing. It just depends on what you're comfortable with. Me, I just know you can leave it on there and just do 4 times 4. I usually write that at the front. so that we don't get confused with x times x4. All right. Any questions for me here? No. Ben, you'll be doing the next one. Anyone still copying? All right, Ben. Let's go. The next one's going to be this one, and then I think, Greg, you can start the limit question. So Ben, last one with no limits. All right. Write it down. xe3 to the x. All right, Ben. What do you want to do for u and dv? Ben, you there? No. Where is he?
Okay, hello. What about now?
Working?
Yeah, can you hear me?
Yes, yes, yes.
Okay, sweet. My u is going to be my exponential.
Your u is going to be your exponential. Okay, yep.
Yep. And then my dv is going to be just dx.
Ooh, there's something wrong.
Wait.
Wait, is that everything?
X dx.
Right, but
Oh no.
what's the problem?
What is the problem?
Well, really, there's no problem because I mean, you could differentiate the exponential. So look, watch, you know,
Mhm.
whatever. There it is, and you can integrate the x. So no problem, right? But you just increase this x, and you're going to make it harder on yourself because when you're going to integrate this, like look, this times this is not a problem. Don't forget, you always have to integrate these two. So your next thing you're going to write is integral of x squared on 2 times by 3 e3x. You just made it bigger.
Uh-huh.
Uh-huh. So what happened is you did not follow this rule. The rule says if you're in algebra exponential, you shouldn't actually do that, even though you can. Look, no problem. It's just that when you're going to try to integrate this, you're going to get stuck because you just made it bigger than it was originally. What you would actually like to do is the other way around. You'd like to make this x and this become...
Yes.
All right, so now what's the derivative of x?
It's just dx.
Just dx, good job. And
then,
then
it's just 1.
Yeah, 1 dx, yeah. And then what's the integral of e3x? Well, an exponential is always an exponential, so at least give me the answer for that.
Oh, it's e to the power of 3x.
Okay, at least that. Now, if we were differentiating, you would times it by 3. But if we're integrating,
you divide by 3.
That's all. So you differentiate the 3x, which is 3. And then if you were differentiating, you would multiply by 3. But if you integrate, you still differentiate, but you divide by the 3.
By 3.
All right. Okay. And then look at this now. Look at if you were trying to integrate this, well, you're just going to be integrating exponential, which is very possible. Whereas before, very tricky. All right. Next line, equals.
So x, then the e to the power of 3 on 3. Minus the integral sign, e.
I might just write in the outside because I think some students are seeing that better. So we'll put the third in the outside. And then?
E3x dx.
Yep. And then look, it just happens to be that. So then this becomes x e 3x on 3 minus a third. What is the integral of e3x? Well,
3e 3x.
E 3x on 3, yeah. And then
Oh wait,
Plus.
oh, 0. Okay, never mind.
it's okay. Plus C.
And C.
You're done.
Yay.
Making a little bit more sense.
Mm-hmm.
Good job. Copy that down, and then we will start exactly the same with limits. And Greg, it's going to be your turn. Just get it out so you can see and write down the question. I guess we'll do this one.
Yep.
Anybody else copying? Greg, your questions is down here.
Yeah.
Anyone copying still? No? Have I lost anyone? Is anyone actually confused? Seriously? Let me know. I need to know if I'm going too fast. Stefan, is it making more sense to you now, for example?
Yeah, it's making more sense.
Are you really comfortable with it? Like, are you starting to see the, this times this minus this times this?
Yeah, the only thing I've got a question about, yeah.
Yeah,
See, the U.
you. Yep.
Yeah. How do you know how much like?
Say it again.
So say it feels like longer than what it is there.
I can't make out what. Say it again. Say, for example.
For example, it feels like longer than X. Yeah. So there's another term in it.
Mm-hmm.
Would you put that other term?
Yes.
U or the D?
With the U.
Okay.
So there'll always be two terms. 1, 2.
Will there ever be 3?
Will there ever be 3? No, because the rule is it's going to be two things that are multiplied together.
All right.
Yeah. So whatever the other things is, so like, I mean, there's another one. So like, that's algebra with a log. But here's another one. For example, here's a sine x with a log x. This would be your differentiating, because LIAT. This would be your integrating one.
Yep.
But there's going to be two terms, always. But yeah.
Alright.
Does that answer that question?
Yeah, yeah.
Hang of it the more and more you do it. But if that's the only question, that is the easiest thing. That's not even a worry. It's more about getting used to, what to differentiate, what to integrate, and how that tick works, and then really just integrating again. So if that's the only question, that's easy. That's not even a problem. You'll just get used to that. I can guarantee it. All right, you guys. So now we've got limits E and 1, and we've got to include that somehow in our working out. And it's not going to be too difficult, I promise. You've just got to learn how to actually include the limits part of your working out. All right, Greg. So
Yeah.
let
So
me just write this down, and then go ahead. U,
U is going to be ln x,
of course.
and
dv,
dv is going to be x to the power of 7 dx.
du,
1 on x dx.
v.
That's x to the power of 8 over 8.
Okay, then the idea is we've always written this times this minus this times this, but when we are writing u times v, so these two multiplied, technically it's already been integrated. That's the idea. Because these two have already been integrated, when we've got limits, we just have to write them with the square brackets.
Yeah.
So we can pretty much straight away sub them in our next line.
Yeah.
But with the other one, with the integral sign, no, you still have to put them in there as part of your integrals, because you still have to integrate this.
Yeah.
So this one here, already in there, done. Just sub them in. That's going to be easy. This one here, no, you got to keep it in because you still got to integrate. So what would this bit be? bit bigger.
That'll be x to the power of 8 over 8x dx.
Yep, and what's x to the power of 8 over x?
That's x to the power of 7 over 8.
Yep, and then over 8, let's just write it in the outside.
Yeah.
If we can start doing that with constants, I think you won't get anything wrong with your integrating. All right, next line. Next line, let's sub this bit in. Log e. Log e is 1 because that cancels out. So the first bit is e to the power of 8 on 8. Sub in 1. Log 1 is 0, so then this bit here just becomes that. Minus 1 on 8. And then?
That's going to be x to the power of 8 on 8.
And let's finish it off. What do you write now?
E to the power of 8 over 8 minus 1 to the power of 8. I mean, 1 to the power of 8 on 8. Yep.
And then e to the 8 on 8 minus e to the 8 on 64 plus 1 on 64. And I mean, really, if you'd like to simplify everything, make it over a common denominator of 64. That becomes 8e8 minus e8 plus 1, 78 plus 1 on 64. The rest of what I'm doing is just algebra, but let me know if you've got any questions. Let me maybe zoom out.
Sam, you don't have to put it over lowest common denominator, right?
You don't.
Yeah. Oh, good.
But as always, I mean, you guys are in extension 2. It will look good. Because you've got to remember, when you're getting marked, you're going to be a number. And if we can understand who you are from your math, as we mark different parts of your exams, we can actually reward you. But if we see like, oh, you left, say it again.
Oh, never mind. Just finish off and then I'll...
Yeah. So if we see like you're a poor student throughout your working out, you haven't lost marks here if it hasn't been wrong. But if it comes to a part where we're like, well, benefit of the doubt, should we give him a 1 out of 2 or a 2 out of 2, or maybe a 0 out of 2? We're more going to be leaning towards these two rather than this one here. But if we see, oh, you've been, a really top student all the way through, everything's been pretty much perfect, your working out's fantastic, everything works and flows very well, then when it comes to a situation like this, benefit of the doubt will actually give you an extra mark. It doesn't matter. We're more lenient towards this end when we see this throughout the paper. But yes, Ben?
For the square brackets where you did E at the top and then 1 at the bottom?
E at the top and 1 here. This one? The second one or the first one?
Oh, no, the line above. The first one.
Yep.
Yeah, you subbed into E, but what happened to the 1?
Well, what is sub in 1? 1 to the 8 times log 1. What does log 1 become?
0.
That's
Okay,
why.
thank you.
I just ignored it.
All right.
Yeah, you can sub in 1. You have to sub in 1, but I mean, when you do sub in 1, it becomes 0, so it doesn't matter for us.
Yeah. Thanks.
All good. Beautiful. All right, let's go again. I mean, since we're here, why not? I mean, we might as well try this question out. ln x on x squared, 4 and e. 3 marks. 4, e, ln x on x squared. That means 3 marks obviously means 3% of your HSC. Right? You look what stage you're in, and you should be able to get 3% of your HSC. Pretty much by the end of our speed test, like I said, 15 marks. That's 15%. So you can get 15% in integration. Complex numbers shouldn't be too hard once we revise that right in mod arg form. That should be another 15 marks. Graphs, I mean, most of these polynomials actually is easy, but graphs shouldn't be too difficult as well once we revise it. This is all out of the syllabus. Mechanics is in, circular geometry is out, more complex numbers. What I was trying to show you anyways was 30 to 45 marks should be really easy. 45 marks should be really, really easy. Stock standard question. So 50% in your extension 2 paper is already scaled up to 80% raw, 80% scaled. So 50 is 80%. You guys are aiming for about 70, worst case scenario. If you can get 70% raw in extension 2, that gets scaled up to 90. You know, so it's not hard to do really well in extension 2, to be honest with you. But anyways, we'll get to that when you guys need to talk about it. But 3% of the HSC, let's try this. Whose turn is it? Mariette. Let's get 3% in your HSC. All right. It did say use integration by parts, but obviously you got to assume it didn't say it. You have to start realizing that this is an integration by parts question. Why would this be an integration by parts? You think about it all, you go, okay, is it completely square? Is it, can I differentiate the bottom and does it give me the top? No. Is it a u substitution? Maybe if I tried u equals ln x and differentiate is 1 on x, but this says 1 on x squared, so it's not even a u substitution. Is it a trig? Is it a t formula? Nothing's working. Partial fractions, definitely not. And then you remember, oh yeah, by parts. All right. Now, I don't think I've had a student that's got this correct when I give it to them. So be careful. Be careful is all I'm going to say. All right. That means maybe the first thing that will come to your mind might not be the right thing somewhere. All right. Here we go. Let's start. The beginning should be okay. U equals dv equals du equals and v equals. All right. What does your u equal to? What do you want it to be?
X squared. No, ln x.
Yeah, I think ln x. Right? Why is it ln x?
Logs first.
Logs first before?
Algebra.
That's it. Logs before algebra. So ln x. Now, you've already said it where I said that's going to be wrong. Now, dv, I'm just going to give you the heads up. It's wrong. So, what do you think dv equals to? Be very careful.
It's not x squared dx, is it?
It's not. No. Why
Is it
isn't this?
X squared?
Yeah, that's better, right? Come on, you know it's not this because that doesn't show that. This is not that. That is that. Right?
Yeah.
So be strict with yourself like that. Like really pay attention to your negatives, to your fractions. It's really important. You guys go, oh yeah, of course, it's not x squared. That's not x squared. That's 1 on x squared. Dx. All right. Good job. Now, du.
1 on x dx.
Yep. And then obviously we don't choose 1 on x squared here. Oh, I mean, I'll leave it there. Sorry. But we don't choose that when we're trying to integrate. We use x to the power of -2. So what's your integral of x to the power of -2? Add 1 to the power over the power.
1 to over -1.
Yeah, that's all. Good job. All right, and then we do that cross thing. So equals.
ln x.
I might just make this look a little bit nicer because I don't really like it like that for now. All right, -1 on x. Yep. So ln x times.
-1 on x.
So I like to just write like this. Negative ln x on x. And then because you have your limits. Do you agree?
Yeah.
Minus the integral.
1 on x times negative 1 on x.
So what does that become? 1 on x times 1 on x becomes 1 on x squared
X.
dx. But there's a negative there, right? So what's going
Does
to happen?
that turn it plus?
Yeah, of course. Beautiful. And then you still got your limits. And again, look what this is again. 1 on x squared, 1 on x squared. So you're just going to integrate this again. But you already know the answer to that integral, you know. But anyways, you got to do it slowly. So next line, sub in 4. What happens when you sub?
It'll be negative ln 4 over 4 minus negative ln e over e.
Okay, that's that bit done. Plus, now 1 on x squared, when you integrate it, is negative 1 on x. Yeah?
Yeah, and then 4 on e for the limits.
Simplify this. So this you can't simplify, you just leave it as it is. Don't use decimals, just leave it.
Yeah.
Log e is 1. That becomes negative 1, so that becomes positive 1 on e. Do you understand that?
And then, yeah.
Plus, and then again slowly, open bracket, negative 1 over 4 minus, open bracket, negative 1 over e. And then last line, or maybe last line, just fix everything up. Plus, well, minus a quarter plus 1 on e. And then, of course, what's 1 on e plus 1 on e?
2 on e.
Three marks. You've got to be able to do that in about a minute and a half, which is super fast. But as you get stronger and stronger and stronger, I mean, like I said, 20 weeks we're going to be doing speed tests for. You will become really fast with this. You'll know exactly what you're subbing in, what you're doing, what's happening at all points. And needless to say, if you're able to do integration by parts, then you can pretty much do all of integration in 2 unit and 3 unit, because you'll know how to integrate logs, you'll know how to integrate inverses, any algebra, trigs, exponentials. You pretty much know all of integration. So integration by parts is the end of integration. All right, well done. Just out of curiosity, Maria, what was harder, the actual integration bit or the substitution bit?
The integration bit.
And what bit has more room for error, the integration bit or the substitution bit?
The integration bit.
Yeah, I think room for error down here for me. I've seen a lot of students make negatives and positive mistakes a lot. Harder, right at the top. So harder, difficulty, I would say at the top, but silly mistakes always at the bottom. Cool. All right, let's keep going. Queenie, and then Rosemary. So let's try that. All right. 2 applications. Are we ready for 2 yet? No, I think leave that for next week. But look, Look, does that look familiar? My booklets? It's exactly the same as the exam. Guys, you'll learn it soon to just do the questions that I want. X squared cos x, yeah, why not? All right, Queenie. Yep, let's do this one. X squared, oh, hold on, sorry. That will be twice. I don't want to do twice. Yeah, let's do that one. Okay, x, ln x. All right, Queenie, just let me know when you're ready.
Yeah.
All right, let's do it. U, d, v, d, u, and v. What do you want your u to be?
ln x,
dv,
x dx.
du,
1 on x dx.
and dv.
X.
Sorry. V.
X.
Integrate this. Integrate x. So you got to increase it by 1 power. What's the integral of x?
X to the power of 2.
Over?
2.
Yeah, perfect. X squared over 2. All right, and then we do that. So equals x squared times
X squared times ln x all on 2.
minus,
Minus x
Yeah.
squared 2 times 1 on x dx.
yep, and then again, x squared on 2 times 1 on x. Well, you know x squared and on x will just cancel out and you're left with x on the top. The on 2, instead of writing over 2 here, I prefer you guys probably to write it on the outside. I think you guys will get it more right. And then, again, more likely than not, this bit here, this component here, will be this again. I think you guys are starting to realize this. So, minus half, and then what's the integral of x again?
X squared on 2.
Plus c, and you're done. All right, and Rosemary, you'll maybe last, we'll say, x squared on 4. Let's go, last one. I would like to do these, I just don't think it's time yet. Reduction formula. No, not yet. Don't do it, Sam. Don't do it. Let's try this and see how this ends up. It might end up to be a nice big mess, which I'm sorry about, Rosemary. But we've got to do it. All right. Integral of root x ln x dx. Are you starting to get the hang of it, Rosemary?
Yeah.
Yeah, all right. U, what would U be?
ln x.
Yep. dv is obviously root x dx, but I just thought we might as well write it like this because we know we're going to integrate it anyways.
Yeah.
What's the derivative of ln?
1 on x dx.
And then integrate x to the power of a half becomes x to the power of?
3 on 2.
Add 1, yep, 3 on 2. And then you got to divide it by 3 on 2. But if you remember, instead of dividing by 3 on 2, we said we can just multiply it by the reciprocal of that.
Yeah.
Rings a bell?
Yeah.
Beautiful. Then equals?
2 ln x, x 3 on 2 on 3 minus
Now,
integral
this
of
constant, just wait, this constant here can go on the outside. This is going to be, I'll do it slower. This is going to be x3 on 2 on x. Yeah, cool. And then look what happens. That's power of 1. 3 on 2, take away 1. Which is what?
a half.
Yeah, right? And like I said, if you guys start to get used to it, you'll know it becomes this thing. Give or take, but it becomes this thing. So that becomes 2 x 3 on 2 log x on 3 minus 2 on 3. And then what's the integral of x to the half?
2x
Blah, blah, blah.
3 on 2 on 3.
Blah. Just out of curiosity, do you know how to write x to the power of 3 on 2 in terms of surds? With just writing root x, so not having a power.
Oh, yes. Yeah.
X root x.
Yeah.
So then this becomes 2x root x.
Log x.
3, yeah. Minus 4 x root x on 9 plus c. That's how we usually would write these halves. I mean, we're always going to have halves because you're going to have surds. You're not going to have like cube roots and stuff. They just don't test that. But so you're going to get this, and I think I also mentioned that the other time. I said you guys want to get used to these. They just work better than writing, I don't know, the square root of x to the power 5. Like that's more year 11 advanced. We don't really do that stuff as you get into year 12. We do things like this. Cool. All right. Anouk, do you feel like you can do one? Do you feel ready to do one or not really?
Oh, you just go easy on me.
Go easy.
Yeah.
All right. Have we done? We've done that one, I think. Yeah, I feel like you can do this. Let's try it. So with the limits and everything. Don't stress. I'll guide you through it. All right. Anyone copying down this? All right. Let's try it. All right, LIAT, which means we're going to probably differentiate the algebra and integrate the exponential.
Yeah.
All right, we've got U, we've got DU, we've got DV, and we've got V. All right, differentiate the algebra. So what do you want your U to be?
Would it be t?
It would be, and then your DV?
E to the power of minus t dt.
Yep, okay, now differentiate T.
1.
So that becomes dt, 1 dt,
Yeah.
and then integrate the exponential. Now the integral of an exponential is an exponential. There it is.
Yeah.
Then you have to differentiate the power. So what's the derivative of negative t?
Negative 1.
And then because we're integrating, we divide by the negative 1.
Yeah.
And then that's it.
Okay.
Now we're going to have limits, so don't forget that. And we're going to multiply these two together. So that will look like this. Negative t e negative t, right? Negative
Yeah.
1 times t. Okay. And then what do we write?
2 and 0.
Minus, but then you know that's a negative as well, so that's
So
going to
it's a
become
plus.
plus. And then integral of true.
Yeah. Yeah.
Again, like I keep saying to everyone, look, these two are the same again. You guys got to keep an eye on for that. So you already know what the integral of this is. It's this thing here that you've already integrated. There's your limits. All right, sub in 2. So it'll look like this. Negative 2 e negative 2 minus sub in 0. Well, 0 times anything is just 0. So that's nice. That's gone. Plus, what is the integral of this thing? Well, you've written it here. Yep. So that becomes negative e negative t, technically. And then 2 and 0. Next line. Plus sub in 2. Look at my use of brackets, you guys. Like, don't take the risk of trying to put everything in without using brackets. Because look how many negatives there are, and another negative here. Oh, it's just a mess. All right. Anouk, what's e to the power of 0?
1.
What's any number to the power of 0? 1. So that's minus 1, which means that becomes plus 1. So your answer is minus 2e minus 2 minus another e minus 2 plus 1. Rearrange. Minus 2 minus 1 more is minus 3.
Yeah.
E negative 2s plus 1. Feels good to
Yeah.
be able to do that. Yeah, usually does. If you're able to eventually execute this, you guys, like I said, you're done. You can assume 2 unit, 3 unit, 4 unit integration done. And pretty much all of mechanics would require integration by parts. So I can't start mechanics until every single one of us can say, we get this perfectly. And that's why I said it will probably take us 3 or 4 weeks to wrap this up. Okay. What I'll do is what I want to do next week, which is looking into 2 applications of it. So we might not start with that one. Hold on. I'll start with is that the same? EX cos x? It was. It's just got limits. Okay, that's fine. I'll just do it without the limits first. All right. Okay. And you'll see why you've got to use 2 applications. I mean, I don't actually ever teach it as 2 applications. I like you guys just to learn why we're doing it. So, I mean, in this case, you can see what happened. You got this thing. How do we integrate this thing? Well, lucky it's exactly like this and blah, blah, blah. But you're going to realize what's going to happen when we get to this step here. All right. E to the x cos x. So again, we write this out. Now we've got a trig and we've got an exponential. And I've said usually if you've got it like this, you might as well differentiate this guy and integrate this guy. So that's the strategy we're going to go for. We're going to differentiate the cos and you're going to integrate the exponential. Okay, so we're going to differentiate the trig. So u is going to be cos x. Du, if you guys can't remember the derivative of cos, do this. Remember this trick? Negative, negative. Going down was differentiating. Going up was integrating. And It's not that hard to remember to do this. But the derivative of cos is negative sine, not just sine. So be careful with that. dv, well, we said we're going to integrate the ex, and then we're going to get v as ex. Okay. Now, before I write the next line, can anyone see a problem? We've got to be able to identify the problem before we can get the solution. Come on, think about a problem. All of this is right, by the way. So don't look at it like that. Forecast the future. Think about what's going to happen, what you're going to write, and what the problem is. Come on, I'm sure some of us have thought about it, but you're just shy to say it. Forecast the next few lines, and what's a problem you see happening? Anyone? All right, well, I'm going to pick them. Let's see. Let's go with Greg. Greg, do you feel like you can see something happening or a problem occurring?
Not too sure.
Not too sure, but if you had to take a guess, forecast the next line. Now, what do you see occurring? What's happening? What's the biggest problem?
There's
What's going to happen? Is this going to be a problem for you?
no.
Is this going to be a problem for you?
Yeah.
Yeah, right. Look what's going to happen. Just forecast it a little bit. You can tell eventually you're going to get a question that's going to say, hey, integrate ex sine x, which is as difficult as the original question, right? I'm sure you guys could have seen that. You got to learn to do that, right? All right. Oops. So, and that's not a problem. It's not a problem because we're going to have a solution for it. So let's see. This one here becomes ex cos x minus the integral of these two multiplied. Well, negative and a negative makes it into a positive now. So you've got plus ex sine x dx. So you've pretty much, like I said, you've got a similar expression to the first one. How are we going to integrate this? Well, to integrate this, you've got to do integration by parts. Now, you have to, it's really important here, you must pick your u with the same family you chose u at the beginning. So if you chose an exponential here first, you must choose an exponential here first. If you chose trig here first, you have to choose trig here first. You don't go and change it, because if you do, you're just going to end up with the exact same solution. You're just going to cancel everything out. It's going to come back to the same thing. So be careful with that. You choose it from the same family. So your u becomes sine x. Your dv becomes ex. Your du becomes cos x dx. Derivative of sine is cos. V is just ex. Okay, so your next line. Next line is this. Plus, now you do by parts again, twice, right? So it's going to be ex sine x minus the integral of ex cos x. Now you're like, oh, what the heck? Now I'm back to the same problem I had here again. So you're not going to go do by parts again, because what's going to happen if you do by parts again? You're going to end up with this result, and you're going to keep being here all day long. Right? But the fact that you got the same result, and it's a negative, and it must be a negative, it can't be a positive, you're going to realize why in a second. And the fact that it's a negative is this. So now, isn't this the same as the original question that I had? Right? Isn't that what we're integrating? We're integrating ex cos x dx. And that's the same. So I'm trying to solve for this, technically. Anyone have any ideas of what I'm going to do to this thing? Don't overthink it. I'm trying to solve for this. Come on, give me an idea. Ben, I feel like you're usually pretty good with just saying stuff. So,
Would you just differentiate it?
not differentiate it.
Okay.
You're trying to solve for, you're trying to, okay, let me say it again and give it one more shot, right? Wait, the question was, find the integral of this, ex cos x dx, and we wrote the integral of this is equal to this, blah, 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 which means eventually we got the integral of ex cos x is equal to this plus this minus, again, the same question, integral of ex cos x dx. But I don't really want this here.
You just substitute it for like something else, right? Would you?
You're kind of close, but it's not right. No. All right, good shot. When you're gonna hear what I'm about to say, you're gonna be like, oh, makes sense. Anyone else? Think about it. You're trying to solve for this. I don't really.
Make it equal to 0.
No.
No, okay. I'm good.
Close. Again, you're thinking of the right idea. Like you're in the right space.
Is it factorizing?
Would it be
Not factorizing. No.
too simple to say like plus it over?
Yes, absolutely. As simple as that. Why don't I just plus this over to this side? Well, what's the integral of ex cos x plus ex cos x dx? Well, isn't that 2 lots of these? Just like any other solving question. And then what do? You just want one of them, so you're going to divide by 2. You're done. Plus c. That's it. See how simple that was, Ben? Like you've got one thing here that you don't want, but you can just plus it to this side. You've got 2 of them now, and divide it by 2. You're pretty much done. Makes sense. Yeah. Yeah, I know. It's frustrating because you're like, damn, it's so simple. But, it's okay. It's good to see it like that. You're solving for this integral, or you're solving for, let's call it a y, and you've got a y here as well. Well, what are you going to do to it? You're just going to plus the y. And that's what happens with these ones all the time. All of these double integrals, or double integration by parts. They're always going to just revert back. And that's why I said minus. If it was a plus,
it'll just cancel
it out, which is a problem. Yeah, so if you've done a mistake, you're probably going to get a plus. So minus, you bring it over, becomes 2 lots, you divide it, you're done.
Yay.
Yay. And that works for all of the, so like this one here would be a double. That one there will be a double, yes, will be. So pretty much I think the ones that have trig and trig and algebra higher than x. So if it's x squared, x cubed, there'll always be a double. So that will be a double. That one won't be a double because once you differentiate the x, you're going to get rid of it and you're only going to have trig. So that should be a single. But you don't need to worry about the whole double and single, right? What your aim is just to start with integration by parts, and then hopefully you'll do what I just said there. You're kind of forecasting and go, oh yeah, I won't be able to integrate that. Oh, that just means I've got to do it again. But I've got to pick the same family for my u and for my dv. And once you do that, this will happen. You bring it to one side and done. All right, we're going to literally do all of whatever questions we've got left from this. I don't need you to do this for homework. We're going to do it all together. So none of this for homework. Again, but if you haven't caught up with your partial fractions and all that stuff, highly recommend just keep going. The next 5 questions. If you have been doing it, do the next 5 questions. But this will be for homework. I'll send this booklet now. This will be homework. And then we will probably finish all of this next week. And then the week after, we'll start the last bit. which is this just continued forever. And you'll understand that once we get to it. So that's good. Monday. You guys are killing it. I know you're probably hearing it from me all the time. That was with the general students. Now you're probably hearing that from me all the time, but seriously, absolutely amazing. You should be really proud of yourself and your achievements up to this stage, because you're killing it. I don't think there are many Year 11 students that can actually say they've done integration by parts and get it to the level that you guys almost get it just within a lesson. So you're doing super well. Keep it up. I will send that across to you now, and I will see you guys on Thursday, I guess. If you've got any questions, stay back. Otherwise, all good. You can start heading off.
Thank you.
Ciao.
See you soon.
Thanks, Sam.
You're welcome, Chris.
Hey Sam.
Hey, Anouk.
Yeah, I'm good with all the partial fraction stuff, and I'm starting to get this. But the thing is, everything before that, I need to catch up on. So, can we do that in the Saturday class? Like, are we heading towards that?
Use substitution, yes. Heading towards that, no, you would not be, because that would be Year 12. Use substitution is a Year 12 topic. It's not a Year 11 topic.
Okay.
So on Saturday, we're heading towards finishing off most of like Year 11 extension 1 and stuff. You won't see U sub until term 4 of this year, which is fine.
Okay.
And don't even stress, because I mean, term 4, you're just starting complex numbers at school.
Yeah.
But so it's not a big issue. But look, the best thing is, I think during the holidays, the next holidays, if you keep that on record, we can actually set up a few lessons for us to go through use substitutions and all the beginning stuff of integration.
Yeah.
All
Okay,
right?
because everything between completing the square for
Yes.
at the start of the booklet and partial fractions I'm missing. That's
Yeah.
the gap in my knowledge.
Yeah, done. No
Okay.
problem. No problems.
And I'd probably need to go through completing the square again, because I learned it off some sketchy YouTube video. It's not too good.
Yeah, all good. No, look, if I ever see that, it won't be a big problem. See, the thing is, our next topic, which will be mechanics, which we won't start for another, I don't know, I think at least, I don't think we'll be doing mechanics even this term. I think it'll be next term, right? Because the integration is still a bit bigger. Like we've got that reduction formula and stuff. But anyways, in mechanics, it's mainly partial fractions. Actually, I think 99% of the time it's partial fractions and integration by parts.
Yeah.
So it's not really going to be completing the square, because that's just like a simple 1 mark, 2 marker that's just given for everybody.
Okay.
So it's not a big issue. Believe me, if you can say that you really know by parts more than anything else, you're doing exceptional.
Yeah. Okay.
All right.
Okay.
Good work.
Yeah.
Good work.
Thanks, man. I'll see you on Saturday then.
See you Saturday. Good job.
Yeah.
Bye.